Welcome back to the final lesson of week 6, and in this lesson we're going to look at the relationship between Boolean logical expressions and the equivalent logic circuits. So in this lesson we'll talk about the order of precedence among Boolean operators because that's crucial to everything that follows. Then we'll look at how we can make a logical expression to match a circuit, and then how to make a circuit that matches a logical expression. Of course, this is how it works inside the computer when the computer works out the answer to a logical expression. So there are 4 operators: not, and, or, and XOR. And if we see a combination of several operators in an expression, we do the nots first, then the ands, and then the ors and XORs. So it's a bit like multiply and add and so on in a mathematical expression. And just as in a mathematical expression, anything that's in brackets gets worked out first. And then once everything's at the same level, we just would go across from left through to right. So let's look at how we can make an expression from a circuit bearing all of that in mind. So here's an example logic circuit. You'll recognize this, we used it last lesson. And I'm going to make a Boolean expression which is equivalent to this circuit. And I'll know I'm finished when my expression contains no letters apart from A and B. But for now, I'm going to use the other letters as I build up the expression. So C is not A, and X is C and B. If you feel that you're not going to remember that as you're doing a task, write it in. It's absolutely fine to write it in. Okay, so let's build an expression that is equivalent to this circuit. We start at the end. This is how I do it. I start at the end of the circuit. And here we have the final expression is X, and it is equivalent to C and B. Now, even though it's a very simple circuit, we haven't finished yet because our expression includes C, and C isn't one of our inputs. So we need to go back even further, and we're going to change C into what it is. C is not A. So our expression is now not A and B. Or we could write it in words like that. And our expression is now entirely in terms of A and B, the inputs, and so our task is finished. So the circuit on the left is equivalent to the expression X equals not A and B. Look at another example. Again, this will be familiar to you. I've labelled the inputs and outputs. C is A and B, and Z is not C. So let's write this down. Z is not C. Our expression is not yet in terms of A and B. So now we're going to substitute what C is. And C is A and B. You can see that the A and B comes before the not, so we've put it in brackets. That's to get the precedence, because otherwise not comes before and. So we need to do the and before the not, so we put that in brackets. And that is our final answer, or we could write it in Boolean terms like that. It's the same thing. Okay, so that's how we make an expression from a circuit. Basically, making a circuit from an expression is the same thing, doing the same thing, just the other way around. So let's have a look at some examples. In fact, I'll go through one worked example with you, and we'll make a circuit to match this expression. X is not A and not B. So a bit more complicated. When we do this, the best way to do it is to start with whatever has precedence, because that will be the first gate that the electricity goes into. So which is the first gate? Well, A and not B has precedence because it's in brackets, but we've still got two operators in there, the and the not. So which gate are we going to put first into the circuit? It's the not, because not has precedence over and. So you don't have to write it out in full like this, but it's the not. Looking at that expression, the gate we have to build first is the not gate. So let's do that. Not B. So we've started to build our expression. What is the next gate that we have to add? You're probably ahead of me. What's the next gate? It's the AND gate, isn't it? Because inside the brackets it says A and not B. So we've done the not gate, so now we have to do the AND gate. And we're feeding the input A in here as well. I've nearly finished making the circuit. What do we have to do last of all? Well, the final gate, because there's one more operator that we haven't added yet, is the not gate at the end. So there we have it. We've got a circuit that produces the output, not brackets A and not B. And once we've created a circuit to match the expression, we can make a truth table. So remember to label all the intermediate states, and there's the truth table. Did you manage to get that? So let's just recap. You need to know the order of precedence. Let me just quickly go through that again. Brackets come first, then not, then and, then or and or. Make an expression to match a circuit by going backwards and making it simpler and simpler until it's only made out of the inputs. And make a circuit from an expression by starting with the gate that has the highest precedence and adding gates until you've got the whole expression.